In this video, we're going to be doing another example of drawing Lewis structures. So this is a continuation of the previous video where we went over the steps for the basics of drawing Lewis structures. This time we're going to be doing an example with NO2-. The very first step is going to be determining the central atom. This is done by determining the least electronegative atom. So as a refresher, electronegativity increases as we go up and to the right on the periodic table. Oxygen is further to the right than nitrogen, so nitrogen is less electronegative than oxygen. This means nitrogen will be our central atom. Then what we're going to do is place the other elements around the central atom. So with nitrogen in the middle, the two oxygens will be on the outside. Then we are going to draw a single bond connecting the central atom with every outer atom. That will look like this with a single line. Each line represents 2 electrons going into the bond. Next, we're going to complete the octets on all of the outer atoms, and we're going to do this by adding lone pairs. Each oxygen currently has 2 electrons because each bond has 2 electrons. This means we need 6 lone pair electrons on each oxygen. That will look like this. Then we need to complete the octet on nitrogen. But first, we need to see if we have any more electrons left to use. We're going to do this by counting the total valence electrons for the molecule. As a refresher, the way we're going to do this is by looking at the group number for each element. The group number is the number at the top of each column. So since nitrogen falls in group 15, it will contribute 5 valence electrons. And since oxygen falls in group 16, it will contribute 6 valence electrons. Finally, because our molecule has a charge, we are going to take that into account. A negative charge will contribute 1 extra electron, whereas a positive charge will remove 1 electron. So in total, 5 electrons come from nitrogen. Each oxygen contributes 6 electrons, and there are 2 of them. And then the negative charge on the NO2- contributes 1 extra electron. So this adds up to 18 electrons total that we need to use in our structure. So now let's compare our structure to the number of electrons we need to have. If there are still electrons left to use, we will place them on the central atom. This structure that we drew has 16 electrons between the bonds and the lone pairs. Remember, every line is worth 2 electrons and every dot is worth 1 electron. So that makes 16. But we just determined from the last slide that we needed 18 electrons. That means that we have 2 electrons left to place on this molecule, and we are going to put them on the central atom to make nitrogen look like this. If the central atom has a complete octet, we can move on. However, if it doesn't, we will need to give it more electrons until it has a complete octet. This nitrogen currently only has 6 electrons. That means we need to give it 8 electrons by forming a double bond with one of the oxygens. We're going to do this by moving 2 electrons from one of the oxygens into a double bond. And it doesn't matter if you do this from the left or the right oxygen. What will happen is those 2 lone pair electrons will now go into a bond. That way, oxygen still has 8 electrons, but now nitrogen also has 8 electrons too. Now that we have used all of our electrons and everything has a complete octet, we're going to validate our structure by calculating the formal charges on each atom. So remember, the formula looks like this. The formal charge is equal to the number of valence electrons minus the number of lone pair electrons minus the number of bonds. We will calculate a different formal charge for each element. Ideally, these charges will be as close to 0 as possible. And if we have charges that are larger than +1 or -1, this is a problem. So if you ever see charges that look like +2 or -2 or larger than that, that's when you know that you need to make some changes to your structure. So for nitrogen, our formal charge will be calculated like this. Nitrogen has 5 valence electrons. It has 2 lone pair electrons because there is 1 lone pair on the molecule, and it has 3 bonds. So that works out to be a formal charge of 0. The left oxygen, which I've highlighted in yellow, has a formal charge of -1. Oxygen has 6 valence electrons. This oxygen has 3 lone pairs, which is 6 lone pair electrons, and it has 1 bond. So that gives a -1 formal charge. The second oxygen, highlighted in green, has a formal charge of 0 because the oxygen has 6 valence electrons, 4 electrons in lone pairs, and 2 bonds. So that works out to be 0. You'll notice that not all 3 formal charges are equal to 0. However, that's not a problem in this case. The formal charges need to add up to the charge of the molecule. Because NO2- has a 1- charge, the formal charges must add up to -1. So it's impossible for all 3 to be 0. However, these are the lowest possible numbers we can have for the formal charges to equal -1. Once again, if you ended up with a -2 or a +2 anywhere, that's when you know you really have a problem. But this structure looks good, and that's how we know that we're finished with drawing it.